Okay, so the last time we continued implementing our Messenger application, and we made good progress. So now we should see where we can continue. One thing that was still missing would be a way to display the contacts. I think, or did we edit this? Let's see if this is working already. I do not remember for sure what the last state was. Let's see. Why did I save that? Copy full path. Yeah, here. And we had our debug here where we can run multiple instances. So we see there Q Messenger, and what was it? I have to check the command line argument which we have devised for the mechanism. Okay, it was just instance. So just instance. Let's say instance 1, and let's connect. Right, so we get a connection, but we don't get a entry made. So what is still missing is the ability to see which other connection participants we have found. So we will start and work on this next. Of course, we need to close our applications here again. And also one more thing that we probably should add is that when we close the socket, that then the chat should go into a disconnected state. But let's do this one by one. First, as said, we want to implement the contact list. I think we did that in source. So that will be somewhere here. Q Messenger. Look into the header, and we have here our 3-widget chats. So that's sub-widget and 3-widget contacts. So what we will want to do is to add entries to this widget, and what we will also need will be some mechanism to know when we need to change something. So in our contact manager, we added we have here this function try add or update, which will usually add some entry, and it is invoked in a couple of places. For once it's invoked, of course, here when we actually get a contact, and also it's invoked here when we get new contacts. So let's first create a new signal. Fine. On contacts, contacts changed, which we'll use for that, and we will want to invoke it whenever we get a content update, because we assume that there probably will be something new, and if not, it's just a small additional amount of computation, so it should not be a big problem right now. We could later, of course, improve this by checking if there was one of these try-adds that returned true, and only then invoke our context changed. And the next place where we also want the same thing will be right here. But since this is just done once, so here we can really emit contact change only when try or update contact actually told us that there is something that is needed to be updated. So in our Q message, again we go to the header. We add now a slot for that event. Oh, I think small detail. We said this should be a signal. Signals, and usually we don't start signals with on. So let's quickly fix that little oversight. Right, so we have here our signal. And here we have the slot. We just need to connect everything, and then from within it we will update our list. Contact chat manager. Yes. On contacts changed from chat manager. Let's connect to right. No, that's the wrong. That's the wrong around. We have first the sender and then the receiver. On context changed with messenger, with this messenger. Right. So first the signal, then the slot. And we don't want this. We want that wasn't chat manager. We want contact manager. Right. Then we have everything. Good. So first of all, we could of course just put a breakpoint here and see if it works. So let's do that quickly. Right, and then we need of course to start another instance to connect a chat to one of our things, and we get a notification as expected, so this works. And now if we start another instance and connect it again somewhere else, we still should get a notification, this time from here, so the slot is working as it should. Then let's stop it quickly. Right. So here you will want to change our p contacts. Oops. P contacts. And what we will want to do here is update the list, but in a way where we don't like rebuild the list each time from scratch. So a good strategy here is to create a few helper variables, so a qmap, for example, with a qurl s key and a q 3-item widget, 3 widget item old map for top level item count e++. So and we should just use a qstring, that's easier. It could work with URL probably as well. So let's see. Item is equals contacts top level item at e item data column 0 qt user role qt user role comma to URL is equals p item. So we create a list of everything that is already in our view. Then in the next step we will iterate through everything that is on the contact manager. Let's quickly check if we already have a function exposing this. Yes, we have here this get contacts, so we can use this. get contacts, pair contact, manager get contacts for each not wait, is that is sorted by string? Do we want this to be sorted by string? Do we sort by name? Name. Okay, so if we sort by name, in this case we will change this here to q string, and then we'll have everything by name. That's fine as well. To string. Right, q string name comma keys. Though we probably could also go with just directly accessing the contact to be faster. And as if I remember correctly, we have stored name on contact, so that should get name. Yeah, so that should be a better implementation. And what we now do is we want to find this item or create it. So tree item widget item is equals old map take. This is one of the functions I mentioned earlier that you would need two lines in when using STL containers. In this case, we are removing an element from the map, and at the same time maintaining a copy of it for local use. And if this item does not exist, then we need to create it. And we'll need to add it, so insert top level item and was it add top level item. Insert would require an offset where to insert, but we just want to add to the end of the list. And if this, and at this point we could update additional data. For now we only had, I think, one column, but let's go back to our thing and add a name and URL, so that we can, or let's call it address, that we can have actually two values. And here what we want to do is we will want to well, first, one thing I forgot, set text null comma p contact get name. And we also want this, in this case we will here just use the text. Right, and then we will of course again set text, but this time we will set the first column and we will set this URL. So get URL to string, and we could set data again column 1 comma role qt user role comma, and then we will set the URL directly so that we don't need to convert it again from string, but we can use Qt's internal representation. Right, and the last thing to do is we will want, so in case some users were removed, we want to get rid of them. So the way this works is everything that is left in the old map are entries which are no longer present in the new map, so we will want to remove them. For each item comma old map, and the way Qt works is that we can just directly delete the items. We don't need to remove them first from anything. They have a reference on the view in which they live, and if they get deleted, they are automatically removed from that view. So this is quite nice. So let's test if this works. We should, as soon as we connect, obtain a list entry for the connecting client already, and when we then connect to the other one, we should get more and more entries. connect, zack, and then we start another instance. So we already had one, two. We'll connect to any of them, and we should see them in both. And as you see, it worked in both. I'm just thinking, why is one? Okay, apparently this one was called test user, while the other one did not get a name. Yeah, this one was just user 1, while this one was user 2. This one was test user. But one thing we see is that this one just got the test user back, but did not get all the other users. So we can quickly try it out again. Yeah, so what is missing would be a mechanism that would send back a list of all the users to whomever is connecting, but we should probably implement this as a request. So we will change now our code a bit and add this query. So when we go to our chat manager, now we want the chat session. Right, so we have somewhere our on connect. Right here it sends the name and the port. Then we'll just send another command, send control, get we'll just list, let's just call it list, and here we have some string argument, and we could specify that we want to send list 1, and the opposite to it, list 0. So the idea is that we say we want a list, and if we say list 1, then we also say we want updates for the list. If we don't say list 1 but instead list 0 or something else, then we won't want any updates. So we will need for this session a flag that tells us whether this was set or not. List updates. By default it will be false. And then we go here to our processor, and so if list, then we had the param. So the param will be to int as if this is not 0, then update list, and then we also need to send, and this is not true. Then now what we need is to send the list of contacts, of all contacts to the current contact. So we want all the contacts except ourselves. That should be fine. Just thinking why this in this side, this should have triggered already an update in both directions. So let's quickly check. And we forgot to use this variable, so we will do that later. But now we'll quickly check whether the listing works both ways. Now, so instance 2 connects to the test user. Now instance 1 connects also to our test user. Nope, we did not get a reply back. Let's see why is this. Debug, detach all. We want to connect. We'll just start another instance from this. Debugging active command line arguments, instance 3. So if we start this now, it will start us as instance number 3. What's it complaining about? It wants to I'm not sure why it wants to compile it again. I can try to try to run it anyhow and hope that the symbols are up to date. It was failing because we have still open instances here. Yeah, and we still don't get the one entry we want. Let's quickly connect to one of the already running instances. Message on this port is a good candidate. Chat manager, no, chat session. One breakpoint here, and then we will start instance 3 again. Connect. So we are obtaining the entry, then we get user 3 with its URL. The question is why our on context, why this does not act the way we want. So let's see what this is connected with. On contact should be connected Q messenger. With session messenger. Maybe we forgot to connect it to anything. That could be also. So here we connect the chat manager. Here we connect the other thing. Right, here we are connecting it. So this is good with our own signal. So we should end up in contact messenger on contact. We should end up here. So let's see what we do. Try update. Yeah, and this will return false, and then we will not broadcast anything. That will be the problem. We can put it outside Dave. I'm just thinking whether this will cause us in any scenario to send this too often, but I don't think it will not. So let's try that. So broadcast to everybody. No, that is not great. I think we need to change our session here. Instead of this on connect, what we want to do is we will want to be more targeted with what we are doing. Connection messenger, manager, skip URL, write data from data. Data is here. I think we have this. We have this only here. I have this only here. Because of course of the broadcast. So we will need to make a new function that especially sends only one list to only one user. So he will emit. Whether it will be an emit on. So emit. Emit list request. We just provide the URL. We need to make a new signal for it. Right. Okay. Then we go to our contact manager. Add to it a slot. And then we need to again do the same mechanism as we already did with this on connect. Do I see here a small mistake? This should be just signal. It's fine. Let's leave it with this name. And list request, so our chat session, or the chat manager will have a on list request again as a signal. And then here we'll be connecting on list request so that we can then in our other part properly handle that. So contact manager, wait, contact manager here should be on list requested, so that should have been in the session. That it's already. Do we have all of them? Chat manager. List request. I think we have all of them, or except for the main connection. And also, since we here have now added this, we will need a body for the function. Right, so we have this, then now we go to our queue message here and connect request here on list request. Okay. Contact manager. Here we will put a breakpoint. We'll run it. It will not compile because we have open windows. Can I close them fast enough? Yes, I can. So then we should, when we connect to this, get this on list request call. And when we get it, we should we won't have anything to report back, but it's important just to see that we get it. So first we go here and then it failed, so somewhere we have not connected everything yet. Let's see. Chat session on this request, right? Here we have an error. Chat manager line 32. Chat manager line 33. Signal. Probably somewhere the name is wrong. So this has a on list. Right, and the session address list request, not on list request. That's why it failed. Yep, now it's fine. And when we look at this broadcast message in the chat manager, we got URLs from contact. So here what we wanted to do is to check whether this helper were at contact. It was on chat session. We will broadcast this to everyone. So either we remove the parameter and just assume that it's always 1, or we have to copy it onto the contact. So I would say, for simplicity, for now, let's just not request anything, and we'll later look how we can make this more elegant. Actually, I will just remove it since we will need to put it somewhere else anyways. Right, so to complete this now, where were we? Chat contact manager. So let's quickly copy the format that we used initially. Need to go for each contact in the contact list. So const pointer reference, comma, contacts. Then from contacts we get name. From the URL we get the URL, so we have our data for each individual contact. We don't want to send the same user back, so if URL is equals a contact URL, then we skip that, and else we will do the broadcasting. So like here, I just need the right datagram to we need a socket as well. We have the socket data we have as well. Why is it complaining? We have the URL. Should be happy with this actually. Data is of the byte array, data is of the upstream. That's the problem. To UTF-8. Oops. Right, so URL, yeah, because we sent everything to the one that is requesting it. Okay, that should be working. Let's try it out. So now when we connect to this one and we start a second instance on a different port, then we get the list. Voila. 1, 2, 3. Wait, why is this user? User 3. Oh, right, because I changed this. Want to always be instance number 3. Let's quickly stop this, and then we will remove that argument quickly so that we have it being the test user again. And well, at this point we already have the list, as said, working nicely. So what I think would be a good assignment here, since we already have populated a mechanism to populate the list, will be to add some features like a double click event. So homework from the 30/11/2023 one, add a to be contacts on the should open a chat with that contact. Okay, and some guidance how to do this. So Qt widget has a signal that is already suitable for this. It does not even need to be explicitly enabled. It's called item double clicked. So use item double clicked, and there you get already the tree widget item and the column where the click was observed. For the column we don't care. And to get a connection, what we can do is so to get a connection, then extract the name from get check for safety that item exists in the list, and if so, start using the contact pointer. And some additional homework, optional, add a context menu to the view. So the context menu can be added. There is a standard slot for that on the Qt widget itself. So we can quickly see if we find it. So tree view, so tree widgets, derived from tree view, which is derived from abstract view, which is derived from scroll area, which is derived from frame, which is derived from QWidget. Finally. You might need to set the context menu policy, and there is the signal custom context menu requested. So let's add some guidance for this. Okay, so that's that. We could of course improve this also a bit by adding something that will show us if a chat already exists. Oh, and one more thing to this option here will be check if a chat is, and if so, bind it in front instead of creating a new one. So we only want one chat per contact. We don't want to be able to open multiple chat sessions with the same user. So of course, before starting a chat session, it will be recommended to check whether such a session already exists. And what else we could do is we could, for example, make this entry display differently if there is actually an existing chat session. So we could check for that. If chat manager, what did we implement on our chat manager? Let's see. Not contact chat manager. Okay, here we don't have much useful. We only have this one map that has a chat session that we can use to resolve our primary pointer. So let's add a function which will give us a session or give us nothing if the session doesn't exist. So get chat session, and it should take a URL as parameter. And if it returns something, then we can mark it bold, and if it returns nothing, we don't mark it at all. So let's quickly add a body that just returns nothing. And so here, get chat session. We need to get the URL again. Contact URL, and if this is that is not null, then we'll change it. So to change the way this is displayed, so get font column 0 q font is equals column 0 font punct set boolean. So we set it to true if this is not 0, and then the item set font will only make the first entry boolean. That should be good enough, right? But of course this is not yet working. So here, let's see how we can best find this out. Ideally, we'll just create a second map. Chat manager h q map q URL comma, which would then again have just a pointer chat sessions by URL. But we will of course now need to use this properly. So first of all, we can use the value function to get something without adding it if it doesn't exist. It's again a function which STL does not offer as a one-liner. So in STL you could get from a map use a square bracket operator to get an element in one line, but if this element does not exist, then it would be created for you. And here we actually don't want to create elements, we just want to get one if it exists or get its default value if it does not. And you can of course do it in STL, but it's like 3 lines or so. You use the find function to get the iterator to the element, then you check whether the iterator is not end, and if it's not end, then you return the value of the iterator. If it's end, then you return the default value. So this complicates things, as is apparent, and is one of the reasons why the Qt things are so nice. So here chat session by URL punct insert. That complicates things, because we don't have the URL yet. We only get it once we get the port from the other side. We could change this to work by name, but then we have the same problem. So in this case we skip this. We'll add this later. Here we can add it because here we have the URL. Comma, and of course if anything gets deleted, chat closed. And we don't have the URL yet, or do we? Let's see. Chat session. We have a get URL, so we could take get URL to remove it. URL punct. Oops. Remove by URL. Okay. And now we only need to take care for this case here when we have an incoming communication. If I recall correctly, we have another signal on what was it? Info changed. So we could use this one here. Session on info change did not have any arguments. With this on info change with no arguments, we need to add the info change to our session. On this sorry, here. Wait, on info change is here. And yeah, and what we do with that. So we have our info changed, and then what we basically want is to check whether it already has a valid port, and then set the URL if it hasn't yet been set. That is still not really elegant, because we will get the info change also when the name changes. Let's see. How did we implement that? So we have our alright, so we need name and port, so the expectation, well, it always changes, and here we have only one on contact. We could use the on contact because it's only triggered once both values are available. So that is probably reasonable enough. So we go again to our chat manager. This one I will comment out for now. This one will need some changing because we'll break it up in a signal and a slot. Slot on contact and contact. Chat manager. Here we need to change, so the signal connects to slot. On contact. So this is only a small change here. Right, and this one we have said we comment this out for now. Slot. Emit contact. Name and URL, and here we can insert it where it should go. On contact, we would have the sender, but we don't care for the sender. We can directly use the URL value path. So this is we need the sender, of course. We need the sender, otherwise we don't know what to assign here. Then we need so zack fetch at session, and URL gets URL, and we emit on content. And we need to do one more change here. On contact gets connected with the signal. Wait, that was the wrong way around. This way around. Right. Okay. So this should work. And here we add it to the URL. So let's see if this works. The expectation is that now when we connect, then we will always display it in bold. And then we can also test if we close the chat window that it will stop being bold. And one next thing to do will of course be to add this close detection for the chat itself. So you see now it is bold, and if we close it, close doesn't work. That was a homework assignment. Haha. That is of course not great, but you can in theory close the socket by closing the other end of the application. So I think I assigned the close button quite a while ago. Right, that was 16/11. So this would be due today. So I would say during the next lecture I will just build this in so that we can use it, because this is actually a nice thing to have. And that is the final deadline for this homework assignment. So by next week this must be completed, otherwise, since it will be shown how to do it, it will no longer be gradable in the lecture. So for now we'll just work with by closing the window. That also closes the socket. So we go to our chat session. It has a close signal, chat manager, on chat close. That should actually work, right? But it did not emit, so the other side did not just emits chat ended and specifies the session. I think we at least should have chat ended here, on chat ended, right? So we could on chat ended always trigger a on context changed from here to trigger a UI refresh of this of the state of the connection state. So as soon as this starts, we'll start again a couple instances. 1, 2, 3. We'll connect all of them with the first instance. And now when we close, it doesn't work, okay. Let's see why this doesn't work. Show chat session. Emit close. Let's well, where do we trigger close from? We only have a button that closes it. We did not connect this connect to close, and that's already the error. We don't need to test anything. The error is apparent. On disconnect, oops, that should automatically trigger close. So let's recompile. Let's now try just with one, because it will be faster. Nope. Something is not working as it should, so we connect again. On disconnect, this is triggered. Then here emit close should be triggered. Okay. Then we go here. This was not triggered. Chat, and this was not triggered. We don't have any errors regarding connection errors. So let's see what is missing. So we emit closed from chat session. In chat manager we have connect. Oh, on chat close is not connected with anything. Then we forgot to connect it. Yes, we did. So that of course explains it. Right. So what was the right function name? On chat closed. On chat closed had no arguments. And here we want to connect chat session closed with okay, like this. Okay, let's try again. Yeah. This we knew that was already working. This works as well. And voila, it now works just fine. So zack, 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 zack. Right, we don't want to watch this anymore. So here, what we also would want is this Windows to show that the chat has ended. Then we will just write something into them. Chat session close. Here, where were we? Disconnected. Then we will just just add where we had our text. Where we had this receive text. We don't really want maybe to abuse this, so let's see. I think we had a different object which yeah, chat tab, which had on receive text. We will add here a void on closed. So we need to connect this, and then we will set the line edit to be read only, and we will write some text to it. So chat session closed. unclosed. Okay, so we have a new line. Set read only, and chat log. Yeah, we just append a text. Maybe just oops. Asterisk 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 disconnected. Or we could also just write this to note that the chat ended at this. Right, we need to also set the value. We can of course set read only false later on, so we might want at some point to add a function to resume a already closed communication channel, so that we just reopen the socket. That would be a bit more convoluted, but it would not be too difficult, I think. Right, so we need of course start a new instance again and connect, and now we can of course test this, and then we can disconnect, and now we cannot send anything anymore. The connection is closed. We could also in principle write here in the title bar that close or something like that, but I think for now this is fine enough as it is. Okay, and so that was already quite a bit code. Are there any questions? Okay, if there are no questions, then let's see how we continue from there. So our chat client already has quite some usefulness. What else would be good to be added? We could add a chat menu here, which would always reference the open chat tab. Then we could actually add there some close options, so it would not conflict too much with the close button that is to be implemented as a homework. Or we could look into adding some file transfer ability, so that we can send a file if we want. What else would be useful? Yeah, I think that file transfer is the next best thing that we could implement. So I will start by adding a chat menu, and then I will add a send file to that chat menu, and then we can go from there. So Q Messenger, Q Menu Sterne, MP Chat Menu, Q Action, send file. That is as simple as it gets. We will not be assigning an icon to it just now. So now we add action, send file, comma, this, comma, on, and file. So we need this slot to be added. Q message on chat, void on send file. Okay, and wait, what is complaining about? The semicolon is missing here. Chat manage. Right, and we'll set this as enabled false. It should only then be enabled if there actually is a chat which is operational. So let's see. We have on tab. No, it was. We have not implemented this, so let's add it. Let's add a slot that will be triggered each time we change the active tab. So void oops, D is missing a void. On tab changed. Okay, on message on tab changed. Chat. They call it chats, or how they call it? Tab widget p chats. So okay. Oops. Connect. Signal. Let's quickly see how the signal was explicitly called. I think it also had an argument. Right, current change. This one is good. Comma this, comma, and we will add the index here, of course, to our on tab changed int to our slot. Okay, so here we will be able to track changes. Let's see if this works as expected. It might be triggered at the very beginning when we insert this tab that just says empty. This would be something we would not want. Need to close, of course, the other instance again. Okay, it wasn't triggered, that's nice. Now let's see if it gets triggered if we connect. It will be triggered because we removed the... It's actually triggered even twice, so this is not ideal. Although for our use case for now, it would be even good enough. It just is not pretty. So let's see again what are the standard. So first we receive a change to -1, indicating that well, it was changed to none. Then we get again an index of 0, indicating that it changed to the first one automatically. If we would add a third one, third tab, then it would probably not be triggered, as we are not switching the tab. Only once we actually actively switch it, it will trigger this then with the next index. So this is working quite okay. So let's see. Chats tab was item? No, I think it was widget. Yeah, widget at index. And when we insert things to chat, we use objects of this type. So the type is equals q object. The qt object cast macro ensures that we only do valid casts. So if the object can be cast to this type, this will succeed, else it will return a null pointer, in which case we want to return. Also, we will not want to try to get a widget from -1, so if this is equals -1, then we want to return as well. Alright, and then we just return, we don't need a return parameter. Also we want to set what was it, pair chat menu, set enabled false, but only in the first case. This case here should not happen, so we just want just in case bail out, but we don't want to do anything else. And other than that, here we will just set enable to true, although we should maybe only set it enabled if there is still a connection. No, we will always enable it, and then the connection, if a connection exists, will have an effect on the sub items. So we can from this get the session, I hope. If not, then we'll need to add a getter function. Let's see. Well, we have the session, but we did not implement a getter function, so let's quickly do that. Get session. Sec we don't need to check whether session is valid, because the way we implemented it, session must be valid. We don't know whether it's still connected. We will need to add a variable to track the connection state. Connected is, or we could use connection state from the socket. Let's maybe go with that. That will be kind of faster. TCP socket. An abstract socket. Socket state. These are quite a few, so maybe we should ideally get a so use the socket state. We will not use a variable to track the state, but we will have a Boolean function is connected, which will tell us whether it is connected or not. This is an elegant solution. And here internally we can evaluate the socket state. Ampere socket state, always connection state. No, it must have been only state. Okay. And then we just copy all those states in here. Catch case. So unconnected state, closing state. This is kind of connecting even more. Connected state is also connected. Bound state. This would not go into a bound state, it's a client socket, and listening state also would not happen. But we could in principle say, I mean, let's say default. Let's say if we are in any of those three states, we return true. And if we are in any of the two states or a unknown state, or rather invalid state, then we return false. And we need to specify the namespace. Rightio. So go to our messenger. So if this is connected, then send file. Didn't I call it send file? Well, I forgot the P. That's a small oversight. P Send file. It was in one spot anyway, so that's fine. Set in. Oops. The IntelliSense somehow doesn't work properly. Set enabled. We'll cache this value since we will probably apply it to more than one menu item, and we only set it enabled if it's still connected. So if the connection is gone, then we can not send the file either. We might later add additional commands like reconnect, disconnect. Well, that's all we would probably need. But that will be for later. So, and now in the send file, so we have we know we have a connection, so we can think of how we would send the file. So first we would want to know which file we want to send. So there is a queue file dialog. Open. No, I think it was get open file name. This comma caption. We already used this, I recall correctly, in one of the early examples, I think. But let's just do it again from scratch. Caption send file, comma. We don't want to specify anything else. It can be any file. It can be only one file. Q string equals this. If is empty, then return. So there is an argument which can be passed here somewhere. Can it? Nope. It seems not. For some functions you have a parameter which will tell you whether the user pressed OK or cancel. But this one only gives you an empty string if the user cancelled, which is good enough. As long as we know that the user cancelled, that is fine. So we will quickly check if this works properly. And then we will retrieve the file size and send and prepare the file sending. Chat send file. Now we can select some file, and if we press open we will get the file name. Now there is something to consider with regard to this file sending mechanism, which is the exact way how we want to transfer the file. So one would be that we just start sending as soon as the sending party selects the file and says send. This approach, while simple, would not be great, because then the other side kind of has to receive the file or abort the connection, which might not necessarily be ideal. So a better implementation would be where, when we want to send a file, we only send a file offer to the other side, and the other side has to accept that file offer. And only once that offer was accepted, then the communication will start. And the file will be sent. So this is one thing to consider. The other thing to consider is that currently our entire implementation runs in the main thread of the GUI. So this means that when the user, when the UI logs up, then so when the what I want to say is, when the UI will be sending a large amount of data, then the UI will become unresponsive, and we would not want that. So ideally, we should either move the whole sending and receiving of messages into a different thread, in which case, or rather into multiple different threads, so one thread per chat, in which case the way it would behave is that when there are data sent to one user. You cannot send a text to that user, but at least the UI stays responsive, and then you can also at least send messages to other users. So this already would be somewhat an improvement, but it still would not be great, since in such a scenario we would only have individual. So in such a scenario, we would not have the ability to talk to the person while the file is on its way. So the best approach here would be to create a new connection that runs in parallel to our text connection, and which will be used to send the data. And of course, one that will then run in an own thread. We have not yet considered all the aspects how to best implement this, because to create this parallel connection, we would need to on the other end, the user would need to receive a incoming connection and accept it, which would be, of course, not a big problem. But the way we are currently handling things is that as soon as the connection comes in this moment we create a chat session, and we kind of think that we'll be chatting with that person. So we would need to somehow not do that. There are two ways. Well, there are actually a couple ways at our disposal how to best solve this. One option would be to make the connection have a mandatory handshake, so that as long as there was no handshake, the connection will not appear as a chat, but will just be kept in the background. This would be quite a good option. It would also give us a nice defined moment when to add the connection to our list by URL, and when to send the connection details to other clients. So this one approach how this could be done. Another approach would be to use either a separate TCP port that would be only used for receiving messages, for receiving files, I mean, in which case we would have a different server which would then react individually as soon as a connection comes in. It would just only notify the user that there is a file incoming and from whom, and the user would then have the option to receive the file. This would need a second TCP port to be opened, which is not big of a problem, but one might find this unelegant, so to have multiple TCP ports open, which would be kind of unnecessary. So what we also could do is we could use the UDP port for communication and send the data over the UDP port. The problem with this approach would be that UDP does not have any sort of reliable transport implemented. So if we send a large amount of data, it is likely that some of the data would be lost. So we would need to implement an own mechanism to track which parts of the file has been received and which parts of the file are still missing. Which probably would be outside of the scope of the project, so that would be simply said too complicated. So I think from all the options that we have here, probably making a proper handshake for the main port would be most elegant. And this way, if we get an incoming connection for a file, which we can then distinguish based on the handshake, then we can move it to a separate thread where it will not be blocking anything. An intermediate solution would be to implement it such that we send over our current port a request that we want. Well, there is actually another implementation which is, as said, a bit in the middle. It would work like this: when we want to send a file to someone, then we would ourselves open a second listening port just for the file transfer operation, and then send to the other party the port number such that they can connect to us and then receive the file. I think this would all in all also not be the most elegant, because again, if you don't set the right ports open in your firewall, you would you may be able to communicate via text, but you might have troubles receiving files. So from the troubleshooting and usability point of view, using multiple ports would still not be ideal. So I think we will just go with the with changing the header and adding a proper handshake to our chat session, we can later on move those sessions into other threads even after the connection has already been established. So on the Windows side, it's easy to share a socket across multiple threads. And if I recall correctly, Qt will not complain here either. So, well, let's start with that. First thing we will need to change is in our chat manager. When we get an incoming connection, here we already emit this chat started, and we add the session here. So first thing is the chat started will be removed, and we will probably repurpose this on contact event. That sounds reasonable. So we will this on contact event maybe call rename it to on text session. Let's call it on text session. Or we could call it on chat session, and the other one would be on file session. Let's call this on chat session. We don't need the arguments anymore because the other one will be on file session. Because now we have a defined sender, so this simplifies things. So chat session connects to this on chat session, and file session connects to this on file session. On contact rename to on chat session. We stick to sender, and we get from the sender the URL, get URL and the name as well. Name. Okay, so on this end it's it, and the others where we connect here. When we do the connection, oh sorry, did I do it on the wrong? No. We need to change this, of course, in both. Right. Although here the start chat, we kind of don't need this because we already know what sort of session this is. So this does not need to be done. This we can keep. This right by URL. We will want to change this because we can have multiple file sessions, and this by URL would be rather thought for the text session. So chat sessions by URL. Okay, let's leave this like this, and we'll add a Q multimap by URL. File sessions. File sessions by URL. Actually, we could maybe just rename this to text. Nah. For consistency, we'll just leave it as chat sessions, but we could rename the other ones here at the top just sessions. So it would be nice to drop this by URL addition because this is just more typing, and the more you type for the less code, the less efficient everything is. So we just call this sessions. Zack. Zack, 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 zack. Okay. So we have sessions, and here we only have chat sessions and file sessions. Right, so why is it complaining? Created sessions. Oh, we did not. But now it's fine. Right, so if we have here a start session, start chat, then we know it's a chat, so we add it to start session. We'll add a new function, start file transfer or something like that. On chat session, add to chat sessions. On chat closed, we should rename this to on session closed. Because it could be either sort of sessions, we don't know. Okay, so we have our on session close, and now here we will remove from the chat session and from the file session. One of the remove operations will fail because the element does not exist on both. It will be only added to one of them. And here, as mentioned, the remove function of the multimap has an optional second parameter for the value. So while of course values cannot be efficiently looked up, usually there will be only a few, so it will be very efficient to find it by URL and then return it and then remove from the few that were found the right one. So this chat has ended. Actually this does not happen in case of files, so we could actually make this remove should have, I think, a boolean return value. Actually it is an integer. Let's see what this remove size type. Okay, it returns the amount of removed elements. This is even nicer. So we can check if this is greater null, then we emit our chat has ended notification. Otherwise we don't, because then it was just a file session which ended, and also this one should maybe be first. We could in principle improve on this by adding like an else, such that if we remove this already from chat, we don't even try to remove it from file, since it cannot be in both anyways. So what now is missing is the one function which will be triggered. Right, these two ones. Did we implemented them already? Right, we did. We just are missing bodies for them. For this one we already even have one. And the other one will be quite similar, at least for now. We will change it later on file session. So we have our sender. We have here the session. This we don't emit yet. Well, we should emit somehow to notify the user that there is something that, let's say, file offered. File offered. You can use chat session for it. This is good enough. Can then extract the data from there. Chat started. This will be file offered. Alright, so we emit the file offered signal. Here we file sessions add our session to the file sessions, and we don't need any contact emissions, since in this case it is fine. Yeah, we could improve that. We could add to the on file session some arguments, such that the file offered would be like would have more information. We could add the file name, for example, const stream reference file name, and file size. The rest is not relevant. So on session has this, and then of course file offered will have file size, and this plus in addition the pointer to the session. So we will need to change this later on, but first let's change that. Zack. And here we need to specify the right arguments. File session, right. Chat start. We also wanted to add this file transfer start. Void send file URL and const string reference file name. We don't need the file size here. The file size we can extract later on. So we have a session. Wait, we need to add the scope. But this will this will not be a start. Set socket. This will be something, probably something else. We'll think about it later. Sessions needs, but here it will be file session, and we don't emit any chat started or anything because this is more or less a one-way communication channel. We are not, so we do not expect to get like another file in response or anything. Right. Let's see if this builds or if we forgot something. Right, we need to close our existing file. Okay, this compiles and runs. So let's see how far we are when we try to reconnect, just to see that we haven't broken anything yet. Right, it will not work because we forgot to send the right event from the other end. So this will, yeah, it here does not do anything. So we need to finish this to bring it into a working state. We go to our chat manager. We have a new signals. Then we go to our chat session. We had here a signal. We will need to add them. We didn't have signals for either of those. We only had info change and contact and stuff like that. So quick sanity check whether we have connected this correctly. Yeah, file session. I think we don't have any others, only with the incoming connections. Right. So here, then once we connect, so we start from the other end. We have the socket. Here we set the socket. At some point we wanted to send control. Where did we send it from? Unconnect, from the unconnect slot. So now what we would want to know is whether we are a file session or not. So this we will add during the next lecture. For now, we just want here to add one command which will notify the other end that this will be a file transfer, or a command that will notify the other end that this will be a chat session. So we send name port listen, and then we say well, how do we call it? We call send. We could call it start, or we could call it chat. It's pretty much up to us to find the keyword. So let's go with just text. Right, we don't need to specify any arguments again. So and the definition will be that the text will need to be the last thing to be emitted. And then when we go to our implementation here, when we receive text, we will emit that this is a chat session. Emit chat session, and the other option would be a file. and then we would of course emit that this is a file session, and we need the file name and the file size, so this will be in the params encoded. List with split by vertical bar, and we will assume that the first one, or the 0 one, is the file name, and if without if size größer 1, then param 0 to long, else we assume that there was no file size. So we'll have the file name followed by the file size separated with vertical bar, and when we get this, then we can set both parameters. If we don't, then we only set one of them. Right, one more thing to consider is of course how the sending of a file session will work. So we will need to have an auxiliary constructor that will take a file name, chat session. So socket is an optional parameter. In this case we don't have one. We have a qstring reference const qstring reference file name instead. And if we have this, we know that this is a file session. The other one, whether it's a file session or not, we will see depending on what further communication will there be. So we can set here a file name qstring variable, so that we can then use it to distinguish whether there actually is a file name or not. And what we then need is of course to if file name, so if the file name is not empty, then we don't send name, we don't send we should send name and port, so we send name and port always, but we don't send list. We'll make actually an else here instead of the return. It's not more elegant. And then we just specify file name plus vertical bar plus q file info file name punct size. So now we have the file size. Is that complaining? Yeah, because that's not a string. So q string number file size. Okay, so this is complete. So now we should have everything that when we start the connection and try to send a message, then it will work and properly send the message. Right, that works again. So since we don't have much time, and I'm usually a bit over time with my lectures, not making the 15 minutes break that is usually scheduled, I think this would be a good point to quit for today. We will continue the next time with implementing the actual file transfer mechanism and the own thread and so on, so that we can nicely send files between the two clients. We'll be also able to add some other nice features. So let's maybe quickly make a to-do list for the next time. So to do using the session, add a file transfer, add a file transfer window in which we would be able to see the progress, showing the progress of the file transfer. So there we would see the, as mentioned, the progress of the file transfer as such. Right, and this would pop up on both ends. We will use a progress bar to show the actual progress. We could add some sort of bandwidth limiting, but I don't think this this will be necessary. So I think it will be fine if we not limit the bandwidth, but instead just transfer as fast as we can. Usually that is what the users would want. Another thing to consider with regard to our design is that we could do without creating the connection before the user accepts, so that instead we would just send a message to the user whether the user wants to accept on the existing connection, only then start the new connection. But this would make the acceptance of the connection a bit more complicated, because then we would need to kind of remember that we accepted a file from that user, and then when the file comes, then accept it automatically. So I think we are good with our current design. Also, we usually expect that if we send a file to someone, then the person will be expecting that file and will accept it. So the reason to have a deny option with regard to receiving files is really only as a safeguard in case of someone sending unsolicited files to people, so as an abuse prevention of our chat mechanism. Usually we can assume that communication over TCP will be flawless, so it should not introduce any errors. But since the checksums on the IP packages are rather short, there is a certain, not zero, probability that there will be an issue. So what we will add here, I'm not sure if we do it to the next lecture or as a homework maybe, we add a file hash to verify transferred file integrity. So this way we can verify. So what this means, a hash of something, or generally of a string or of a data blob, is a cryptographically derived number, which is usually comparatively short, like 128-bit or 256-bit, no matter how large the input data was, and it is it is generated by executing a mathematical function which takes into account the current state plus whatever new data are added. So you can add data in chunks, you don't need to provide it all the data at once, and the function generates an output which is designed to be as unpredictable as possible. So the goal is that if you provide a certain input, then you get your hash value as output, and as long as you provide the same input, you will always get the same hash value out. But you should not be able to, in any meaningful way, be able to modify the hash input to get a desired output. If this would be possible, this would be really bad, because it would allow you to create a file which looks as it is the same file because it has the same hash value, but has a completely different content. Hence, such a behavior is called a hash collision, meaning that you have two inputs which generate the same hash. And ideally, hash functions used in real life should not have, I cannot say never, it should not have hash collisions. Of course, realistically, since the output is smaller than the input, there will always be some hash collisions. But in the ideal case, the only way to find those collisions should be by just trying every possible input until one randomly finds one that works, which of course with a 128-bit number is pretty much unfeasible. So there is not enough computational power in the whole world to iterate even once through such a large number, so this should be safe enough. The reason why there are much larger hash numbers used, like 256 or 512 bits, is because most of the functions at some point will be attackable, so smart mathematicians will find ways how one can, by providing the right input, get some degree of freedom of what the output will be, rather I should say degree of control of what the output will be. So while it will still usually require a lot of trial and error, the computational complexity will be reduced with as the cryptanalysis of the existing hash functions progresses. At least that's the expectation with many hash functions that happened, like with the MD5 hash, which by now is considered to be broken. So you can, with affordable computational effort, generate any hash collision you want. So hence using much larger hashes usually alleviates this problem somewhat, because then you see, okay, if there are known attacks and the hash is not longer as secure, then you would, for example, if you reduce it, the attack complexity by 50%, then you would cut a hash value down from 256 to only 128 bits, but this still would be too much for a practical hash attack, because you still could not try out all these values to get a hash which entirely is a one-to-one collision. Usually what you can do with hashes and so is that you have a short piece of the hash, and then you just try values until this short part of the hash matches, and then the rest will still not be matched. So you can use this as a kind of gauge to how good your attack is without having to effectively try to create an actual collision. And of course, for example, the SHA-1 hash algorithm, which usually worked with 192 bits, which is kind of a bit of an odd number. There was a SHA-0 defined initially with 128, but apparently they knew from the start, at least some people in the NSA, that this will not be safe enough, and the first standardization already got some additional bits to be 192-bit long. And of course by now SHA-1 is again already considered broken, so for any really secure application, SHA-256 is the minimum that is recommended to be used. Right, so this much as a detour to hash functions, but now let's continue to our implementation in our file transfer algorithm. So the idea here will be that maybe in addition to the file name, we'll also ascend the file hash, and then on the other side, once the file has been received, the hash function can be executed on the file content, and then the hash value can be compared. This way we don't need, for example, to send the file again and then see whether we got 2 times the same thing, but we just have the hash value and we only compare the hash value, which allows in a very bandwidth preserving way to validate whether we have received the right content. How we handle the case where we see that the file was corrupted for whatever reason, I have not yet decided. There are in principle 2 options what we can do. One is that we just, well, there are 3 options. One option is we just don't do nothing. We just say, okay, file transfer failed. The user can retry. Second option would be to have an automatic retry. Then, okay, the transfer didn't work. We try to transfer the file again. Already at this point, we could have some sort of, in quotation mark, smart error handling. Since we receive a file of the same size, we would just overwrite the existing file from the beginning and then periodically check whether now the hash matches. So if the error was somewhere at the beginning of the file, we could soon abort the retransfer, because then we would have the right file. Of course, if the error is in the last portion of the file, then this not so smart error handling would be pretty much useless. It will only save us a small percentage of the file that will need to be transferred. So what can be implemented as a actually really smart error handling mechanism is to generate multiple hash values from the file. So in the simplest way, just separating the hash values in chunks. Sorry, separating the hash in separating the file in chunks. So let's say we will take 9 megabyte large chunks or 10 megabyte large chunks, and we will calculate a hash for each chunk, and then we'll just send all the hashes to the other end, and then the other end can see, okay, which of the hashes are not matching, and then just retransfer those selected chunks. Now, of course, how well this works will depend on the chunk size and of course on the file size. One approach to improve on this would be to have a variable chunk size. So let's say we will always break the file up in 100 chunks, no matter how large the file is. We would expect that at most one chunk will be broken. Well, if not, then well, we need to transfer more, but ideally we would only transfer the one broken chunk and then the file would be fine. So with such an approach, we would say that in case of a corruption, we always have at least 1% overhead in order to retransfer the broken piece. We could try to improve it by having like a double level error correction. So first we find the chunk which is broken, and then we again break this chunk up in 100 pieces and then check each piece individually. And then it would already be at a really good corruption recovery efficiency. Which of those methods, whether we will implement just a smart method or even the subchunk method, we will see as the lecture progresses. There are a few nice things that can be demonstrated when using such a more advanced error correction scheme. But I think for our use case, especially given that we are only communicating with one other party, the easiest approach really will be to implement it really such that we break it in 100 pieces, and then wherever we found an error, we then break this again up in 100 pieces. And instead of calculating all the data on the client side, on the sending side directly, we would just ask for the first hash sets, and then we would just say, okay, now we want just a hash of this one individual piece. And also we could do it such that we would not even calculate the individual hashes at the beginning. We would only do this if the other party says, based on the main file hash, that the file was broken, and that we actually want to do some error recovery. This would be a simple implementation. However, it would require the other side to often hash the file more than once. Actually, you hash it once to get the main hash, and then hash it the second time to get the primary hash set, which might not be desirable depending on the size of the file. So if the file is a few 10 gigabytes in size, then we might not want this, and we might want an even smarter method, which would be to use a so-called hash tree. So what is done here is you calculate the hashes already at the highest resolution, and then to get just one hash, and in order not to transfer all the hashes, you just transfer a hash of the hashes, or rather you create a tree where you have first your leaves, so every hash of the 10,000 parts of the file. Then you take the first 100 hashes and hash them together into one. Then you take the other 100 hashes together into one, and so on. So you create your intermediate 100 hashes, and then you hash those together and create one hash of those 100 hashes, which will be then your master hash. This approach is quite illustrative. Usually when doing this in practice, one can do it, let's say, much more convoluted by generating a hash out of every 2 hashes. So you really create a tree with a huge amount of independent levels, which would allow you to have a very fine control of how large of a part you want to get more error correction data. But that might again get too complicated. So I think then the approach with let's say a hash tree with only one intermediate level would probably be the best trade-off for us to make something that is simple enough that it can easily be understood, and at the same time that already illustrates the operation principles of more advanced data recovery of files in transit. Also, during the next lecture, we will take some time to discuss the final project, so your final homework, since I think in December there are some holidays, and then January will be already the time to finish it. So I think this will be good if we can, during the next lecture or to the latest day after it, find some nice assignment for you to implement on your very own. And while you will be doing that, there will be no more individual homework related to the Q-Messenger project which we have here. I will just finish the implementation of the different things and show you how to use Qt in many nice ways. One other thing to be mentioned is that the homework that was assigned some time ago, I already mentioned this during the lecture. I think the homework from the 16th, right? With this closing, I will implement this during the next lecture. So if you have not submitted this homework yet, this week is the last opportunity to do so, because once I have implemented that and shown you the reference solution, and then of course no more homework on that subject on that assignment can be accepted. Okay, that's that. And if you will not have any lectures on Friday, then have a nice weekend. If you have nice lectures, then have a nice Friday. Bye bye.